All right, so let's get right into this. So in lesson 19, we're going to be talking about directed line segment and vectors. Pretty much what that means is we're going to graph vectors in space. So not so much from the origin, but if I give you a vector and I give you a starting point, you can find its endpoint. It's really all we're doing. We're going to connect different vectors together to find out where else they could land. But that's pretty much all we're doing. It's just simply graphing vectors in a real world type of situation. Well, it'll be in space for now, but we'll connect it to real world situations throughout the week. All right, so a vector can be used to represent a translation that takes one point of an image to a different point. Hence, here's your initial point. Terminal point would be the new point, right? Whatever the vector v tells you to do. Go up, go down, left, and right, however the situation is. So if we know the coordinates of both points, we can actually figure out what the vector is as well. So if you know the initial point and the terminal point, then you can find the new point. Believe it or not, I just went over this in my college pre-cal, so you're like caught up now. We are kind of bypassing. It's kind of cool to do this. This is exactly what they're doing as well. So in exercise 1 through 7 here, it says several vectors represented by arrows are shown below. For each vector, we're going to state the initial point and the terminal point and the component form of this said vector. So again, remember, initial point is the point it starts. Terminal point is the point it goes. And then the component form would be the vector itself. How did you get from initial to terminal point? You can physically look at it, and we'll be able to mathematically do this as well. So you already have those. So let me get mine up. Oh, I guess that's okay. So that's all number one. Okay, we'll do this together. All right. So we got different letters. So let's work these out. I'll do a couple with you until you understand the process. I'm going to show you both ways. All right. So define vector v. We'll start there right here. So this is your initial point. So initial point for v. Initial, I think there's an A there. Point is 2, 4. Terminal point is negative 2, 5. And then to find the component form, remember component forms the things that have the inequality symbols. Man, I tell you, I literally, am I yelling? Gosh, I feel like I'm barely hear myself. All right, yeah, just let me know if I start yelling. All right, you can do this visually by just simply almost doing like rise over run, like a slope kind of concept. I remember we do the X first, then the Y. So if I want to know how far I went from here to here, I can go 1, 2, 3, 4. So I went 4 to the left. That would mean what? So there you go. And then I went 1 up. So that would be what? 1. All right. So that's how you can do it with a visual graph. Like if it's graph for you, super easy. A lot of times though, especially on the ACT, they'll just give you the points and ask you to find the component form. To do that, you simply have to take, I'm going to label it like this. But the initial point we'll call x1, y1. The terminal point we'll call x2, y2. What you're trying to find is just the difference between the x's. So what I'm going to do is I can do x2, bless you, minus x1, comma, y2 minus y1. So here's like a algebraic approach to this. So when I do this, I get negative 2 minus 2, because that's what the x2 and x1 are. And then this is a 5 minus 4. So when we work this out, what's negative 2 minus 2? Negative 4. And what's 5 minus 4? 1. So you can see you get the same answer either way. All right, so again, if it's given to you as a graph, you can just visually figure out the answer. But if you're given just the points, then you're going to need to know the algebraic approach as well. So what I want you to do is go ahead and do the other 6. Either method. You can just visually look at it, get the answer, or you can do the algebra to get the answer as well. So that's what you are doing. We need a U. We need a W. We need a B. And we need an A. Is that all? 1, 2, 3, 4, 5. Did it say 7? Oh, it just said several. Okay. So you need to do the other 4. Any confusion on that? Is it very straightforward? Yeah, go ahead. Very good. Let me write that in definition form for you. Initial point. This is your starting point. Terminal point would be the ending. It's with an arrow. So your initial point is right here, and then the ending point is going to be the one with an arrow. Already got it all, Jacob? Okay. Yeah, you're supposed to be doing the other four. U, W, B, and A. Very good point. What part of the straight line? Is it horizontal or vertical? So what X or Y is not going to change? For which one? Be the X. Very good. For a horizontal line, the Y would be 0 because therefore that's not moving up or down. All right, ready to go over it? All right, so what's the initial point for U? What's the terminal point for U? Now, you can either look at it or you can do the equation, but when you're coming from the origin, the terminal point's actually super easy. What's the terminal point? 4, 2. So when you come from the origin, the component form will just be whatever the terminal point is, right? Because that's literally what the difference would be. All right, let's look at the initial point for W. Okay, you probably start it backwards. Remember, you have to start at the end, the initial point, and then when you go to the terminal point with the arrow, you would go right 4, so that's a positive 4, and then up 2, so that's a positive 2. Did you go from the arrow down to the bottom? Okay, that's okay. That's it's very important that you do terminal point minus initial. So it should be 4 minus 0, 2 minus 0. In past, like in college algebra, when you did like not college algebra, sorry, in algebra, when you did slope, you just did change in y over change in x. It didn't really matter. But this does matter. All right. Initial point for W would be, I don't even know where W is. There it is. -3, 2. Good. The terminal point for W would be perfect. And then what was the component form then of W? Good. So -5 plus a 3 would give you -2. And then -2 minus 2 gives you a -4. Or you could have done left 2, down 4. Any questions there? All righty. What's the initial point for B? 3, 0. Good. What's the terminal point for B? So the vector in component form would be, good. 3 minus 3 is 0. -3 minus 0 is -3. All right. What's the initial point for A? Good. -4, -5. What's the terminal point for A? And therefore, what is the vector in component form? Good. 1 minus -4 gives you 1 plus 4, which is 5. -2 minus -5 gives you a plus 5, gives you a 3. Questions on any of this? Graphically or algebraically? All right, let's look at question 2 then. So in question 2, several more vectors represented by arrows are shown below. For each vector, we're going to state the initial point, terminal point, component form, and magnitude. All right, so we'll quickly review what we just did. So I did not see that. All right, so let's back up a little bit. Let me finish those problems then. Good catch, guys. All right, so let's add the magnitude then real quick. I'll do it in a different color so we can see it. So the magnitude of V, how do we find magnitude? A squared plus B squared. Now, when you are doing a vector in space, we learned it's x2 minus x1 squared plus y2 minus y1 squared. However, when we did the work to turn it into component form, we now just got our A and our B. So we can go straight into the component form there. So this would then be, that's what you can use. If you didn't have component form, then yes, we would have to do x2 minus x1 squared plus y2 minus y1 squared, which we did on the distance formula in geometry, but also in the last module. But once you get the actual vector, we can just go straight a squared plus b squared. So however you want to approach it, because we basically get that vector, you already had to do the x2 minus x1 concept already. We just now have to just square it. So -4 squared plus 1 squared. So that'd give you 16 plus 1, which is the square root of 17. Questions on how to find magnitude? All right, I'm going to quickly do these other 4 so that y'all can begin number 2. So the magnitude of U would have been 4 squared plus 2 squared, which is 16 plus 4, which is the square root of 20. Remember, you got to be able to simplify radicals. What two numbers multiply to 20? Good, 5 and 4. So this is then the same concept as 5, or my bad. Well, let's do this differently. The same concept as 4 times 5, which is in the same thing as square root of 4 times the square root of 5. And what's the square root of 4? 2. So this is the same thing as 2 square roots of 5. Obviously, if you can do that a lot quicker, by all means do that, but that's the process. W would be -2 squared plus -4 squared, which is 4 plus 16, which again gives you 20, which again gives you 2 square roots of 5. Magnitude of B is going to be 0 squared plus -3 squared, which ends up being 0 plus 9, which is 9, which is 3. Then the magnitude of A, 5 squared plus 3 squared, which is 25 plus 9, which is 34. 2 and 17. Can't go any further, so it's just 34. Questions on magnitude or simplifying radicals? All right, go ahead and do number two. Do the same process. Initial point, terminal point, component form, and magnitude. PM group? EOC boot camp. Yeah. The mental physical camp. Mental camp. Ooh, that doesn't sound good either, though. A mental camp. Yeah, I don't know. Preparing for the STAR test. Me? Didn't eat it. Is this freshmen or sophomores? Yeah. Freshmen? Okay. Well, now it's seventh through ninth grade right now. hmm hmm Back in March. I say back in March, last month. Gosh, I can't believe we're already in April. I feel like this year just started. Man, like seven. Let's rephrase it as seven more wake up, forced wake ups. There you go. Till you get a job. And then you get up even earlier than you did in school. Saw a meme that was like, I was so excited to be done with school, getting up at 6 or 7 to get ready. Now look at me, I'm getting up at 4:30 to go to work. Like, rest of your life, you miss out on the best parts of it. All right, do we all have our answers? Are we still working? Oh, sorry. Go ahead. My bad. I say half of y'all aren't moving y'all's hands, so I assume you're already done. It says you don't have to. Oh, because there's you have to. Yeah. There's no more grid. I see what you mean. Yes, ma'am. So once you find the component form, you can just do square root of a squared plus b squared. This is what component form is. Is I actually figured. Hmm? Oh yeah. After you subtract them. Yes, I got you. Yes, you're welcome. 625. How would I get there? Yeah, I mean, it's 25 times 25 is 625. So then 25 times 26 would be another 25, which is 650. How'd y'all get 701?
Oh wait, no,
Oh, that's right. So that's 25 times 26, which is 650. And then now let's add another 26. So that's 676.
I added.
Yeah. So it's 676. But that's how you would do it. Start at a point that you have memorized and then kind of go from there. Or you can do the whole vertical multiplication. For the square roots, for the magnitude, yeah. You'll get, like you're talking about for you, it's a 4-digit number. Yeah, you're doing good. Yes, it should be a 4-digit number for you. The other two are 3-digit numbers. Remember, it's a squared plus b squared. Once you get the components form. Yes, sir. 25 times 25 is 625. Yeah, it doesn't get much harder than this. Till we get to those word problems. But those are your life problems. Like, how am I going to use this in the real world? The actual word problems are exactly those problems. I graded each one of y'all's. There's some work that when I was grading, I just literally have no idea how y'all even got the numbers. But others, I was like, okay, this is where the mess up is. Here's partial credit. So I was able to do stuff like that. Um, yeah, it was, I mean, some of y'all wrote me notes. I responded back to the notes. I think one of them was, I really tried hard on this one. I see, but you kind of messed up here. So, yeah. Well, usually a lot of y'all's mess ups will be in one spot, and then the rest of it was good, but because of that one mess up, it caused the next spot to be wrong, next one to be wrong, and the next one to be wrong. So I was like, I'll give you partial credit for this part, but then so I did the best I could on partial credit. Did she respond? No, that's her response. That's what I get to. I'm gonna start doing that. Start watching y'all take y'all's test code. Hmm, probably just because it's fun. Wait until y'all become an adult. Hmm. All right, what's the initial point of V? Perfect. Terminal point of V. Perfect. Vector or component form of vector V. Good. 15 minus negative 11 is 26. 24 minus 19 is 5. Oop, there we go. And then the magnitude of V would be 26 squared plus 5 squared, which is awesome. So this right here is 770 or 675. Nope, 676 plus 25, which gives you 701. Go ahead. So how could you use Prince? Because these are actual coordinates. These are points. So this is a point and this is a point. Bless you. But for a vector, it is written with these to indicate that the vector itself is the arrow and the line. So it's the actual shifting of the point. Mhm. Right. So if I was to keep this in parentheses 26.5 to a reader, that would mean, oh, there's another point I need to graph. But to a math reader, they would go, okay, you're shifting this point by this vector to get to this point. So this is your translation, basically described, almost looks like a coordinate, and you kind of graph it like a coordinate, but it's written as component form. All right. This time we did the magnitude. All right. What is the initial point of U? Perfect. The terminal point of U. Okay. And then our vector of u. Oh, I don't know what I'm doing here. Sorry. The vector of u good would be, oh, come on now. No, that's right. That's right. That's right. 28 minus 5, which is 23. Okay. And then negative 7 minus 15 is negative 22. So then the magnitude of u would be negative 23 squared plus, come on. Just 23 squared plus negative 22 squared, which gives you what? Very good. Again, if you weren't getting that number, it could be that you weren't putting your negative in parentheses when plugging into the calculator, and then that could cause you to get a different answer. All right, last one. What's the initial point of W? Terminal point of W? Therefore, what is the component form of the vector W? Very good. And then when we find the magnitude of W, that would be negative 10 squared plus negative 25 squared, which should come out to something like 725, because 100 plus 625. Any other questions? Believe it or not, none of those can be simplified. So you couldn't go any further than that. Yeah. Well, there is certain like 3s and 7s could potentially go into it, and then maybe that number could maybe predict go any further. And you could take 5, but it doesn't turn into any other number you can go further with. All right, so get number 3. And it would only give you a decimal. It wouldn't give you the simplified radical form. Yeah, we have gone over that already in this course as a review, but that was a main thing in Algebra 2 as well. So on number 3, we're just going to write a rule for the component form of a vector v shown in the diagram. I kind of jumped the gun on number 1 and actually went ahead and gave you that. So here is the formula. Huh? To what? So 25 times 29. I know 25 times 29 would be 725. What's 25 times 29? Yeah. So what happens is that number can be broken down into 25 and 29, and then the square root of 25 gives you that 5. That's how I get 29. But we can just leave it like that. But good catch. Good catch. All right, so again, the component form is from terminal minus the initial. So this is x2 minus x1, and then y2 minus y1. So here is just a single location where you can have your formula to find a vector in component form. I know we wrote it down on number 1, re-showed it on number 2, but now you have a single place where the formula is. Questions on how we got the formula and how it all kind of produced that? It kind of helps us find the distance of x and y. All right, let's look at number 4. All right, so when we use initial and terminal points to describe a vector, we often refer to the vector as a directed line segment. A vector or directed line segment with initial point A and a terminal point B is denoted by this. So this gives us another type of form. So instead of giving this the name vector V, we can now just say it's a line segment AB, but you would find the same process of doing this. So if we wanted to find the vector component, you would literally do the same process. Again, using this formula right here, x2 minus x1, y2 minus y1. So this is some new vocabulary. You might want to highlight some things. So a vector is the same thing as a directed line segment. So if you see the word, go find the directed line segment, you're like, what does that mean? This means go find its vector. Different notation, same meaning. So if I would say, where's AE at? Okay. If I say this guy is vector V, then I could say line segment AE is V, right? And then if I ask for the component form, then I would just say, all right, terminal point is 0. No, my bad. That's initial point. Terminal point is negative 2 minus 0, and then 6 minus 0. which would then just give me negative 2 comma 6. So I could write it like this, right? So if I see this, it's just meaning what is its component form of the vector. Questions on terminology? All right, go ahead and do B, C, and D. Go find its vector component form. It did not say, and I'm looking at it. No magnitude, just the component form. You don't even have to write out the initial and terminal point. You have to use it to find component form, but you don't have to write it out this time. Just the component form of the vector. Yes. Oh. All right, we'll check these tomorrow and continue our discussion tomorrow. Y'all enjoy the rest of the day, guys.